Dear students, welcome back to our channel. Today we are going to be discussing about a topic called soil compaction. It is comes under third unit of geotechnical engineering subject. Coming to the aim of this class is to understand about what is soil compaction, why soil compaction is necessary, the significance or importance of the soil compaction, the mechanism of the compaction, factors affecting soil compaction, the effects of soil compaction on properties of the soil, different types of field compaction equipment, and also we see about compaction quality control. Then coming to the what is soil compaction? Soil compaction is the practice of applying mechanical applications or compactive effort to densifying a soil by reducing the voids space between soil particles. The compaction occurs when the particles are pressed together to reduce the space between them. Highly compacted soils contain very few spaces, resulting in soil with higher unit weight. Maximum density is achieved at the optimum moisture content or OMC for a short period. The process of compaction decreases the likelihood of settlement after a building, roadway, runway, or parking lot is constructed. The settlement could result in premature pavement failure, costly maintenance, or repairs. By observing the diagram, we are going to be see about the compaction will be occurred on the soil. The soil which is contains three layers of mass, that is air, water, solids. Whenever the compaction is applied, the compaction will be reduces the air content in the soil mass. By reduction of the air, the soil it will be compressed, or the soil particles which will be densified by the applying of the compaction. Then coming to the why soil compaction is necessary. The soil compaction is necessary to increase the bearing capacity and stiffness of the in situ soil and chemically modified soils. The compaction increases the shear strength of the soil by adding friction from the interlocking of particles. Future settlement of the soils is reduced by the increasing of stiffness and eliminating voids, creating a densified soil. The removal of voids reduces the chance of soil settling or shrinking or expanding nature. It decreases water seepage that would lead to deleterious shrinking and swelling soil properties. Then, what is the significance or importance of the soil compaction? The soil compaction maybe increases the density, and it will be increases the shear strength of the characteristics, and increases the load bearing capacity, and decreases the undesirable settlement, increases the stability of slopes and embankments, and decreases the permeability, reduces the water seepage, and reduce the swelling on shrinkage, reduce the frost damage on the surface of the pavement or surface of the subgrade soils, and reduces erosion damage. These are the main significance or importance of the soil compaction. Then what is the mechanism of the compaction? Here three points we are observing, and also we are observing the graphical representation between dry density as well as water content. As we know that, or as already discussed, that whenever the water content it will be reaches optimum amount, the optimum moisture content is the moisture content at which the maximum possible dry density is achieved. Beyond the optimum moisture content or below the optimum moisture content, there is no dry density will be occurred, or sufficient dry density will not be occurred. or beyond the optimum moisture content, the soil which became saturated, there is no use of compaction on the soil mass. That is the way, whenever water is added to lubricate the content surfaces of the soil particles and improves the compressibility of the soil matrix. It should be noted that increase in water content increase the dry density at upper at only one stage, that is optimum moisture content stage. At optimum moisture content is reached, the soil which became more densified condition. That is the meaning of our mechanism of the compaction. So then coming to the what are the factors will be affect on the soil compaction? The soil compaction will be affected by the type of soil, maybe varies from the moisture content, the type of compactors used, and thickness of the lift, contact pressure, speed of rolling, number of roller passes, and the last one is amount of compaction. What is the first type of the factor which will be affect on the compaction of the soil? The different type of the soils which is having different compactive natures. The well graded granular soil that contains a wide range of particles are preferred in construction applications because they can be easily compacted when compared to poorly graded soils. The poorly graded soils which contains a narrow range of the particle sizes and also less conductive for the construction purposes because of it is poorly graded soils. The poorly graded soils means the sum of the particle sizes which are missed. That is the way we are calling as poorly graded. As a well graded soil means the well graded granular soil which contains the equal or the number of particle sizes which are included in the well graded soils. The graphical representation also we can observe the dry density which is highly in well graded soil when compared to highly clay particles or clay soils. So these are the basic difference of the type of soil which will be also affected the type of compaction. The moisture content or water content. Whenever we are adding the water content or whenever we are adding the water to the soil, it is an important role in the soil compaction because the maximum dry density is only achieved when the water content is at an ideal level. That means this point is known as optimum moisture content level. So whenever the moisture content which reaches the optimum moisture content level, the density or the soil dry density which is achieved maximum. That is the meaning of moisture content or water content, which is also effect for the soil compaction, different soil compaction. And type of compactors, wherever we are going to be use the number of type of compactors, the different type of compactors will give different compactive natures and different type of the compactors which are more suitable in different type of the soils. For example, if you take the sandy soil, the vibratory or sheepfoot rollers which are most suitable for the sandy or gravel soil, whereas clay soil, the clay soil which is the most suitable compactor is pneumatic rollers. So like that, the type of compactor also which will be effect for the compaction. So then coming to the another factor, that is thickness of lift. The soil compaction sometimes involves compacting multiple lifts or layers of the soil. The different layers or thicknesses is achieved whenever the number of rollings or the stability of each lift depends upon the one below it is, so compaction of each layer is critical and must be monitored. The establishment of the correct lift thickness is important to find the balance between layers that are too small or too large. A lift that is too large could result in poor compaction. A lift that is too short or too small, that will result in good compaction in nature. So generally the lift thickness typically range from the 8 to 14 inches depending upon the specifications. So that is the main factor to affect the soil compaction. And contact pressure, we know very well about the contact pressure between the soil and the equipment used for the compaction is also important to realize. The contact pressure is affected by the overall weight of the uh, compaction equipment and the area of the soil contacted by the equipment. The higher contact pressure is more compaction will be needed or achieved. Then speed of rolling, either a compaction or compacting roller which is very slowly rolling or slowly it will be moves, there will be a applying of the load is more when compared to higher speed of the rolling process. So the speed of the rolling also maybe it will be also a factor for the affecting of the soil compaction. Whenever the compactor or compacting equipment will be slowly moves, the compaction will be takes place more when compared to highly or quickly moving of compacting equipment. So the different type of the compacting equipment, different speed will be having. Then compacting equipment usually have travel speed is between 5 to 15 mile per hour. The smooth drum roller it will be typically 5 to 7 mile per hour, and sheepwood roller which will be having 5 to 15 mile per hour. And pneumatic rollers also it will be having almost 15 mile per hour the speed of the rolling. So different type of the compacting equipment, different speeds it will be having. The number of rolling processes. So there is a factor called as the number of roller passes. The soil which needs the number of higher number of rollers it will be get more compaction or more compacting nature. At a high level, a number of passes needed to achieve desired compaction depends upon the contact pressure and the speed of the equipment. These two are main things the getting or achieving of the good compaction of the soil. The contact pressure of the compacting equipment is important, and the speed of the equipment also will be important. The contact pressure it will be indirectly proportional to speed of the equipment, because if the speed of the equipment is higher, the contact pressure is very lower, because it will be fastly it will be goes. So like that the number of roller passes is also a type of factor. The passing of number of rollings or rollers passes it will be leads to the higher compacting or densifying of the soil. The amount of compaction is also very important. As discussing earlier, effect of the increasing compacting effort is to increase the maximum dry density and reduces the optimum moisture content. However, there is no linear relationship between compactive effort and maximum dry density. So when we observe the diagram or graphical representation, the line of optimum moisture content is linear in nature. So by observing the linear in nature, the optimum moisture content it will be reaches to the maximum. So it will be comes the maximum dry density will be achieved. So different soils which are having different optimum moisture contents, and also different optimum moisture contents it will be get maximum dry density of their respective soils. Then coming to the effect of the compaction on soils. What are the number of effects which are compaction on the soil properties? The soil properties it will be affected by the soil compaction on permeability, on bearing capacity, on settlement of the soil, on compressibility of the soil. It will be effect on soil structure and texture, and it will be effect on pore water pressure, and it will be effect on stress strain characteristics of the soil, and finally the compaction of the soil which will be effect on swell string aspects. By this way, the number of effects may be happen by the compaction of the soil, and it will be effect on soil properties. How the soil is compacted? This is very important word, how it will be compacted or how the soil will be compacted. Soil compaction is achieved through the static or dynamic force and manipulating of the soil. So here the two things will be happening. One is applying of the static or dynamic force, and the second one is manipulating of the soil. The soil originality, it will be collapsed, or it will be regained, or it will be deformed into another formation of the soil. The original soil condition, it will be deformed or transformation into another form of the soil condition. So there are number of types of field compaction equipment we are going to be used for the compacting of the soil. For example, if you take the smooth wheel steel drum roller, which is having a single drum roller, which is having double drum roller as. And second one is pneumatic tire roller. Third one is sheep foot roller. Fourth one is impact roller. And the fifth one is vibrating rollers. And the sixth one is grid rollers. Seventh one, hand operated vibrating plate or rammed compactor. The number of compacting equipment which are useful and which are suitable for the different type of the soil conditions, or different type of the soils, or different classification of the soils. For example, if you take the smooth wheel steel drum roller, the capacity of this one is 20 kN to 200 kN. That means 2 to 20 times of the weight which is having, and which is self-propelled or towed, and suitable for the well-graded sand, gravel, and silt, wherever which is having slow plasticity. The well-graded soils which are more suitable for the smooth wheel steel drum rollers, and also which is not unsuitable for the uniform sand, silty sand, and soft clays, because the uniform sand or silty sand or soft clay, which are having different in nature, so different properties which are having, that is the way the steel drum roller which is more suitable for the well graded gravel or sand. The second one is the pneumatic tire roller, which is having a number of tires or wheels. These tires are rubber tires which is having, and full width of machine or equipment which is having number of tires, and their dead load is added to given a weight of 100 to 400 kN or 1 to 4 tons, and which is more suitable for the fine soil or coarse soil, and which are not suitable for the very soft clays and highly variable soils. So pneumatic tire roller is more suitable for the coarse and fine soils. And third one is sheep foot roller, and which is having a type of sheep foot or feet, a shape of feet which is provided in the external portion, and which is having kneading action, and it will be more useful or more suitable for the sandy soil and gravel soil. And the weight of this type of roller is 50 to 80 kilonewtons or 5 to 8 tons, and which is also self-propelled or towed, and which is also known as paddy foot roller. And this is the third one. And also we can use for the impact roller, which is different from the others. The compaction by the static pressure combined with the impact of pentagonal roller, which is having 5 directions or 5 sides. So that is the way we are calling pentagonal roller, and which is more impact, which is applied more impact on the soil, and higher impact energy breaks soil lumps also, and provided kneading action. So here two things will be happening: breaking of lumps and providing of kneading action by impacting action. So impact roller, which is most suitable for the wherever the number of lumps are higher lumps, wherever having on the surface of the soil, the impact roller is very much suitable for those soils. Then finally, or coming to the fifth, vibrating drum roller, and here the action of the vibrating as well as a rolling process or compaction process will be takes place, This type of roller is fitted with one or two smooth surface steel wheels which are having 0.9 meter to 1.5 meter diameter and 1.2 meter to 1.8 wide width, and which is also self-propelled vibratory rollers which are now available weighted are 4 to 6 tons of the weight. So here what happened means the vibrating roller it will be rolling on the surface of the earth whenever the passing of the roller on the surface of the soil, and in forward direction it will be applies the vibrating action, and coming to the backward direction from the same process, so there is no applying of the vibrating action, because only one way the vibrating action will be takes place, and coming to the backward direction there is no applying of the vibrating, just simply compacting of the soil it will be happens. So it is sometimes used for the asphaltic concrete works also, and which is more useful or suitable for the sandy soil, and wherever the vibrating is needed, so the gravel soil also there is a suitable for the vibrating drum rollers. And one more is grid rollers. These are also very important rollers which are having cylindrical heavy steel surface consisting of the network of steel bars and forming a grid with square holes and maybe ballasted with the concrete blocks. And they are generally towed units and can operate at speed of 5 to 24 km per hour. Typically, the weight of the grid roller is 5 to 15 tons, and grid rollers provided highly contact pressure, and it will be having little kneading action, and also suitable for the compacting most the coarse grain soil which are most suitable for it. And finally, coming to the seventh one, that plate and rammed compactor, which is used for the backfilling trenches, smaller constructions, less accessible locations. Wherever the higher equipment is not suitable or not permitting to enter into that area, the plate and rammer compactor is most suitable for the compacting or impacting of the soil compaction. So this is very small equipment, and which is most suitable for the building areas or construction of the building areas. Here some of the applications are we are seeing compaction equipment. So smooth wheel roller which is very much suitable for the well graded sand and typically applied for the subgrades of the roadway and runways, and which are not or least suitable for the uniform sands. And coming to the rubber tire or pneumatic tire rollers, which are most suitable for the coarse grains soils with some fines which are having, and which is typically applied for the road construction, and in that road construction also subgrade and subbase courses wherever going, the pneumatic roller is most suitable, and which are least suitable for the coarse uniform soils and rocks also, which are not suitable. Wherever the rocks 300 above rocks which are having, there is no useful for the compaction. And grid rollers, we know very well about grid rollers, well graded coarse soil which are most suitable, and subgrade, whereas the subgrade and subbase course is going on the road construction. So these are the grid rollers are applicable. And clay soils, silty clay soils which are not suitable or least suitable. And one more is also we can see here sheep foot roller or paddy foot roller, though which are most suitable for the fine grained sands, fine grained soil, which are 20% of the fines wherever in the fine grained soil. So there is a most suitable of the sheep foot roller or paddy foot roller. So applications, when we go for the dams, embankments, road constructions, and when we go for the air crafts and highways construction, subgrade layers of the construction, so more applicable for this sheep foot rollers or paddy foot roller. and which are least suitable for the clean gravel or clean coarse grained soils. So, which are more than 20% of the fines wherever which are not suitable for the construction or compaction. Like that, the vibratory rollers which are more suitable for the sandy soil and applicable in a small areas wherever the small patches will be going on. The vibratory rollers are very much suitable and least suitable for the cohesive soils. So vibration applicable only for the gravel and sandy soils. That is the way. Cohesive less soils which are not suitable. What is the cohesive less soils? Clay soil or silt soil which are not suitable for the vibrating rollers or vibratory rollers. So by this way, applicability of the compacting equipment we can observe. So whenever we go to the compaction quality control, the compaction quality control will be done in two things, for the finding of the dry density, and the secondary is water content. The dry density is measured using of the methods core cutter method and sand replacement method commonly used, and water content finding, we are going to be use the war drying method for the taking of the 24 hours. So by this way, water content we can observe or we can find out, and also we can determine by using of protractor needle, or it is also known as plastic needle. That is also very much useful for the finding of the water content. So mainly the compaction quality control will be done for the finding of the dry density as well as water content. Then we come to the how it will be useful, or where we going to be apply this compaction of the soil concept. So some of the questions may be asked in the competitive exams like this. Dry density of soil is increased by the compaction, swelling, bulking, addition of the excess water. So already we have discussed or we have seen the dry density of the soil is increased by compaction. So by the compaction only the dry density of the soil will be increases. Where it will be get maximum, the optimum moisture content is reached. So the dry density it will be get maximum dry density. So optimum moisture content versus maximum dry density. So that is the meaning of dry density of the soil is increased by compaction. Coming to the second question, it will be optimum moisture content or water content. The soil has will get maximum density, minimum density, no weight, no density. So already we have discussed at optimum moisture content or water content, the soil which will be get maximum density. And coming to the another question, in a compaction test, as the compaction effort is increased, the optimum moisture content is dash. So compaction test, compaction effect is increased, the optimum moisture content is decreased, remains same, increases, and increased first and then decreases. Already it will be knows about the compaction test. Whenever the compaction effect is increases, automatically the optimum moisture content it will be decreases. Only certain thing is wherever the optimum moisture content reached, the density it will be having maximum dry density, and then falling of the optimum moisture content it will be takes place, and then compaction effect is increases. There is no further use because optimum moisture content is reached, and beyond the optimum moisture content the soil will get saturated soil. There is no other compaction will be takes place. That is the way the compaction effect is increases. So by this way we can see the soil compaction, and what are the factors affecting compaction, and what is the mechanism of the compaction, and what is the what are the different types of the compactive equipments, and finally how the compaction quality control will be takes place. Thank you very much. Have a nice day.